What is DAX? DAX is Data Analysis Expressions. It's a library of functions and operators that can be combined to build formulas and expressions. Concepts around DAX. There are three basic concepts. There's the syntax, functions, and context. Let's move into a demonstration of what each one of these is. So why is it important to learn DAX? If you want to measure year-over-year sales versus previous year's sales, then DAX can do this for you. Learning DAX will help you compare data over a time range and help you solve real business problems. Let's walk through a demonstration of the syntax and how DAX works. So in the Power BI desktop here, I'm going to go to the Modeling tab and select New Measure. We're then going to give our formula a name, so I'm going to say total sales. And then I got to provide the operator, so this will be equal sign in this case. And then the function that I'm using, so in this case I'll use sum, but as you can see there's lots of functions available to you. And I want to sum the sales, so I'm going to provide the table called sales, and then the column that I'm referencing. So in this case it'll be the sales column. And then I got to close off the formula here, parenthesis, and press enter. So this has now created a new measure for me called total sales. Now in this case it is created in the table called dim country, but I want to change this so that it's actually in the sales table. So I'm just going to click home table and select sales here. Now as you can see, total sales is included that. So if I was to drag total sales measure on here, I'd see the total sales for 2018 is $66,000 in my example. And this can be easily converted to, a card as an example here. Some of the gotchas could be is if the table name contains spaces or reserved words or disallowed characters, you need to enclose the table name in single quotation marks. Now we could have easily this is a fairly simple example, but we could have just dragged our sales amount on here and we would have gotten the exact same amount in this particular case, 66,000. The reason we're creating a measure is we can now use this particular measure in other formulas, which is the powerful thing of DAX. So let's walk through a little more of an example that is comparing current quarter's sales to previous quarter sales. So we need to somehow find a way to get previous quarter. So I'm going to create a new measure called previous quarter sales, and I'm going to use the calculate function at this point. So we're going to select calculate. Now I need to provide the expression. So this will be, this is where we can use our total sales measure that we created in the previous step, separated by comma. So I now need to provide a filter. So I'm going to use another function. So previous quarter, as you can see, previous month, previous year, we could do all sorts of things. So previous quarter. Now the arguments for this particular formula is it needs dates to filter on. So our date's going to be based on our date table that we have here. So dim, and then the dim date is our table, and the date field is the date. So I'm just going to select that. We need to close off this particular formula, and another parenthesis to close off the outer edge of the formula, and press enter. So this is a little more complex, but once again, the calculate function, the important thing is it needs two arguments supplied to it. So it needs the first argument being what are we doing. So in this case, we need total sales, and then the filter portion, which is our previous quarter dim date. So if I was to now drag this onto the canvas, let's see previous quarter sales, and we'll drag the current quarter sales, and we can do that by going to just drag total sales. And we want that by quarter. So I'm going to drag, do a matrix in this particular case. I'm going to drag quarter into column so we can see by quarter. Make this a little larger so you can see. So what we're seeing here is we have the quarter two and total sales of $4,300, and then the previous quarter for quarter three is now showing the $4,300. So as you can see, we're do a lot of things. Now we could also do a variance here. We can compare the current quarter to the previous quarter just by doing a simple formula, but get the idea. Second major concept is functions. Functions are predefined formulas that perform calculations by using specific values called arguments in a particular order. Arguments can be other functions, other formula, expressions, column references, numbers, text, logical values such as true or false, or constants. There are certain categories of functions. There's date and time, time intelligence, information, logical, mathematical, text, parent-child, and other. DAX always references a complete column or table. If you want to return only a particular value from a table or column, you can add filters to the formula. DAX includes many functions that return a table rather than a value. Table is not displayed, but is used to provide input for other functions. Time-intelligent functions allow you to define or select date ranges and perform dynamic calculations based on them. That is what we did in our previous example with the quarter. If you need to customize calculations on a row-by-row basis, DAX provides functions that let you use the current row value or related value as a kind of argument to perform calculations that vary by context. We'll review what context means shortly. There are two types of context in DAX: row context and filter context. Row context applies to whenever a formula has a function that applies filters to identify a single row in the table. The function will inherently apply a row context for each row of the table over which it is filtering. Usually applies to measures. Filter context is when one or more filters apply to a calculation that determine the result of a value. Doesn't exist in the place of a row context, rather it applies in addition to row context. While filter context can mostly be applied by adding fields to a visualization, filter context can also be applied in DAX formula by defining a filter using functions such as all, related, filter, or calculate, which we used before. So let's walk through an example. Let's say I want to have calculate sales for Canada here. So I've created a measure called Canada sales equals, I've used the calculate function once again, and I've provided the following arguments. First argument being my total sales measure, then a comma, then I have my filter context that I'm using within the calculate function. So in this case, I'm filtering where dim country equals Canada. I was then able to use this function. I dragged that field onto here, and I can see that I have total sales by month, by country. And then you can see I have total sales and I have the Canada sales. So my total sales for May was $496 for Canada, and obviously that's Canada sales, and obviously you can see the July sales here broken down with Canada sales in a certain column. So this formula ensures that only sales values determined by the total sales measure are calculated only for rows in the particular filter that we're using, which is Canada country sales. So let's walk through another example. Let's say I have just a simple table here of the total sales by customer, and I want to know how many distinct customers I have. So the way I can do that is, so I have customer count for measure here that I've created, and I would use the function count rows, and I can also use another function called distinct, and then have my table and my customer name column. So in this case, by doing that, I see there's 28 unique customers that exist in my data set. I could also just do count rows by customer name. This would give me the total number of rows returned in my data set without having the distinct in there, which is 197. So let's actually do that, and just so I can show you what that looks like. Let's create a new measure. Customer rows equals, and let's just do our count rows, and then provide the table. So sales table. And we'll close that off. Press enter. Now if I was to drag customer rows in here, and let's change this to, I'd see 197 customer rows are available, and just to prove that number is correct, let's go back to here, select our sales data set, and as you can see there's 197 rows of data in our sales table. So webinar recap. Today we learned what is DAX. We learned about the structure of DAX and the basic components. We also reviewed some basic formulas in DAX to get you started. You can also go to the following URL, docs.microsoft.com, and what I've referenced here. There's basically URL with all the different formulas that are available in DAX for you to use, and some explanations and syntax you should be using, so very good resource to use.